Hi all. So let's see the next CPU scheduling algorithm, which is longest job first. Longest job first is also abbreviated as LJF. Okay, and it is opposite to the algorithm which we learned earlier, which is shortest job first. So shortest job first will pick the process which will have least burst time. But in contrast, longest job first will pick the process which have longest burst time or which have largest burst time. Okay, so in this particular algorithm, we will pick the process who have the largest burst time. So definitely here criteria will be burst time. So here criteria is burst time, and the mode given here is non-preemptive. Non-preemptive means we pick the process whenever we pick the process based on their longest burst time, then till its completion no need to halt the process. Okay, so let's see the example here. In this example there are total 5 processes given, process P1 to process P5, and their arrival time are 0, 1, 2, 3, 4, and their burst time are also given 3, 2, 4, 5, 6. So as usual, first we draw the Gantt chart and then pick the process. So let's draw the Gantt chart. So starting from time 0, there is only one process available. So we choose the process P1 at time 0, and it is non-preemptive mode. That means we will run this process for exactly 3 unit of time. Means whatever be their burst time required, we will run this exactly this much time to finish their process. So it is required 3 unit of time. So 0 plus 3 will be 3. Now the time is 3. So at time 3, how many processes are available? Process P2, it is over. Process P1 is over. Process P2, process P3, and process P4. So can you guess which process will be chosen next? If you see the burst time of the 3 processes P2, P3, P4, the burst time is given as 2, 4, and 5. So what is the largest or longest burst time? 5, and 5 is corresponding to process P4. So definitely P4 is chosen next. So P4, and P4 required 4 unit of time. So 3 plus 4 is 7. 3 plus 4 is 7. P4 is also over. Now at time 7, all the processes are available. Process P2, P3, and P5. And among this process P5 has largest burst time, which is 6 unit of time. So the next process will be process P5. Okay, and process P5 requires 6 unit of time. 7 plus 6 is 13. So P5 is completed. After P5, the next process will be process P3, because 4 is greater than 2. So definitely P3 will come first, and P3 requires 4 unit of time. So 13 plus 4 is 17. P3 is also completed. Now the last process is P2, and P2 requires exactly 2 unit of time. So 17 plus 2 is 19. Okay, so P2 is also completed. So after finishing the Gantt chart, let's compute the completion time. So you can easily compute the completion time by seeing the Gantt chart itself. So in the Gantt chart, the process P2 have completed at time 19. So 19 is the completion time of process P2. P3 is completed at 17 unit of time. So 17 will be the completion time of process P3. Similarly, process P5 is completed at the time interval at the time 13 unit. So P5 here, completion time is 13, and then after process P4 is completed at time 7. So completion time of process P4 is 7, and then last is P1 is completed at 3. So 3 will be the completion time of process P1. Got it? Okay. Next is turnaround time. Turnaround time is completion time minus arrival time. So 3 minus 0 is 3, 19 minus 1 is 18, 17 minus 2 is 15, 7 minus 3 is 5, 7 minus 3 is 4, sorry, 7 minus 3 is 4. And then after 13 minus 4 is 9. Okay. Next is waiting time. Waiting time is turnaround time minus burst time, which is 3 minus 3 is 0, 18 minus 2 is 16, 15 minus 4 is 11, 4 minus, I think here P4 requires, P4 completion time is 7. So I have by mistakenly 7 minus 3 is 4. Okay, just I check it. So here some modifications requires. So process P4 require exactly 5 unit of time. So here I will mistakenly add this process P1, which is 3 unit of time. 3 plus 4 is 7, but here 3 plus 5 is 8. 3 plus 5 is 8. Now process P5 requires, process P5, yes, P5 requires 6 unit of time. So 8 plus 6 is 40. So, and then after process P3 requires 4 unit of time. So 14 plus 4 is 18. Sorry for that mistake. 14 plus 4 is 18, and then after it is 18 plus P2 requires 2 unit of time, 20. Now yes, so here completion time minus arrival time. So it is P4 requires, P4 completed at time 8. P4 completed at time 8. So once again I will compute the completion time, turnaround time, and then waiting time. So what is the completion time of P2? P2 completion time is 20. P3 completion time is 18. P5 completion time is 14. Yes, 14. And P4 completion time is 8. P5 completion time is 14. P4 completion time is 8. Okay. Yeah. Last is P3. P3 completion, P1 completion time is 3. Now the turnaround time will be completion time minus arrival time. Okay. So it is 3 minus 0, which is 3. 20 minus 1 is 19. 18 minus 2 is 16. 8 minus 3 is 5. 14 minus 4 is 10. Got it? Next is the waiting time, which is turnaround time minus burst time. 3 minus 3 is 0. 19 minus 2 is 17. 16 minus 4 is 12. 5 minus 5 is 0. 10 minus 6 is 4. Okay. So you can easily add this turnaround time and find the average turnaround time. Average turnaround time will be 3 plus 19 plus 16 plus 5 plus 10, and divide it with by number of available process. How many processes are available? Here total 5 processes are given, so it divided with by 5. Next is average waiting time. Average waiting time will be, add this column 0 plus 17 plus 12 plus 0 plus 4 and divide it with by 5. So you will get the average waiting time. Okay. So longest job first algorithm is exactly opposite to the shortest job first algorithm. So if you understand the shortest job first algorithm, you can easily compute or calculate the numericals related to longest job first algorithm. Okay. So in the next video we will see the next CPU scheduling algorithm.